Okay, so here's problem number 34, and it's about our confidence intervals. And they ask which of the following is correct. Okay, now, they didn't ask for the definition of a confidence interval. All right, we got two different things going on. These tell us about the confidence interval. These could possibly be the definition. Remember, the definition is if we were to sample over and over and over again. All right, so these are out. Okay, so let's look at A and B. All right, do you see how the answer is A? Because that we're within 0.05, because this is my margin of error of the two proportion. Okay, it's not that the majority of the area. It's not that. So the answer for number 34 is A. Okay, so for 35, hopefully that you read it. And basically what they wanted to talk about is how to put people, flies, whatever, into three groups of equal size. All right, now remember what the word random means. All right, is that everybody has an equal chance. Okay, so do you see here that if we do A, label the first 25s caught in group A, the second, then not everybody has an equal chance to be in group B or in group C. So A is out. And then here, write the letters A, B, and C on a separate sheet of paper. Randomly pick one of the slips of paper and assign the first 20s to that group. And then the next 20. Again, not everybody has an equal chance. The only one where everybody has an equal chance is D. Okay? Okay, now this number 36 is an interesting problem here, and the key word is mutually exclusive. So that means an experiment has three mutually exclusive outcomes. So that means that the probability of A and B is equal to 0, because that means they have nothing in common. The probability of B and C is equal to 0. And the probability of A and C is equal to 0. If they have nothing in common, then the probability of both of them happening at the same time is equal to 0. So 2 is true. Okay, now, if two guys are 0, if the mutually exclusive, that means that A is 0. Let's look at 1. It says A and C are independent. So that means that the probability of A times the probability of C, does that equal to the probability of A and C? Well, we know that the probability of A and C is 0. And in order for whenever you multiply two numbers together to get 0, one of the probabilities has to be equal to 0. So 1 is not correct, because neither of these are equal to 0. One is 0.12 and the other one is 0.27. Okay, so let's go here to number 3. Okay, I'm going to erase what we just got done doing. Okay, so here what we're doing, we have the probability of B or C. So remember the probability of B or, oh, excuse me, I don't want to use that symbol, I want to use the or symbol. Or C is equal to the probability of B plus the probability of C minus the probability of B and C. So the probability of B or C is equal to, now what's this? Probability of A and C we already know is 0 from up here, correct? So this is equal to the probability of B plus the probability of C. So this is correct. So 2 and 3 are correct. So the answer is D.